Hello everyone, welcome to part 2 or clip 2 of topic 5, where we discuss about reasoning and inference and as well as uncertainties. In the previous part we introduced the logical reasoning, and we explained that in logical reasoning that we need to give some like syntax and also semantic for those like syntaxes, and after that we need to build a logic. And this logic, as we explained, is usually based on if then, for example, to take into account as much as we can, or from into consideration as much as we can from the environment. However, even the process is very complex. It has been a lot of work done since 1950. However, the progress in that regard was quite limited, because in reality, when we talk in reality, if we want to build intelligent agent to work with real environment, then we will have a lot of events might happen, and also there could be, or there is usually actually like non-complete or incomplete information extracted about the environment, can be like biased, can be noisy, can be corrupted. So there are a lot of difficulties, challenges in order to make that logical way of reasoning. So it would be much better, much easier to build probabilistic reasoning, and we will see that this probabilistic reasoning can be basis also for more advanced way to build intelligent systems, like based on, for example, machine learning, or for in the decision theory, that for example game theory and so on. So probabilistic reasoning is very important. It can enhance the capabilities of AI. Okay, now just for the purpose of thinking, that assume that we want now to cross a highway. It is not highway this one, but assume that it is highway, maybe two directions highway, and then you need to look like to right, to left, to see what, that how far cars, and then your brain actually computing the approaching speed or approaching rate of the cars toward you. Then of course we don't have that computation in numbers, but that's what our brain do, that looking to the car, they can estimate the approaching like rate of cars, and also they can compute what is time needed to cross the road. Then they give you the command to cross or not. Based on the decision, actually it depends on many things. For example, what is the probability to be hit by car? So for lazy people, maybe they don't care. Maybe they can cross the road, even the probability of be hit by cars is as high as, let's say, 10%. Or 5%. Some others, they are very careful, so they don't cross the road unless they are almost sure that the probability is, let's say, 1 per 1,000, for example, or it is empty road, so it is almost zero. Now this way of decision is based on probabilistic reasoning. So you have this probability in your mind even without computation. Okay, and now assume that you want to cross this road, and you are very in hurry, because for example you want to catch to the train, and after the train you will go to the airport, and if you miss this train you might miss the flight. And so in that case, of course, you can take the risk, and you can accept higher probability of be hit by crossing the road. Maybe you can accept even 15% or 20% if it is extremely important event that you need to catch. So now you can see that you are doing some compromise and some computations in order to take the risk. Of course, some people, they take into account that might be that even the car is quite far away, they might be that it is like not good driver, so might increase the speed, or I might drop, for example, if it is old person, that he might drop or he might get some problem in the middle of the road. So you can see that we have a lot of possibilities here, and we cannot take into very details, but as a human, we think naturally in this way. But how to make this for machines? How make the machine taking or observing different choices and then select the best one? And what is the meaning of best one? So when we say best under what criteria? These things that we are going to explain. Okay, now concepts of probability. So the probability actually is a mathematical branch which gives some quantified measure for uncertainty. So we have usually uncertainty. Actually, we have uncertainty everything, as they said that there is only one certain thing, that it is death, but otherwise everything can be uncertain for some people, at least. Of course, we have different beliefs, and maybe people say have certainty in other things as well. But the thing that no one could decline is the death. So death is a common thing that everyone knows, that for every living thing, they will die one day. Otherwise, we have some uncertainties about everything. Yeah, so I give just a simple example. If we have, let's say, resistor, so we have certain resistor. This is a resistor, okay, and this resistor, the resistance is 1 kilo ohm. Okay, so if I asked you what is the probability that this resistance, it has exactly 1 kilo ohm resistance, surprisingly, that this probability is 0. Yes, the probability that you have this resistance equal to exactly 1 kilo ohm is simply 0. Why? Because I ask why it is not 1.00001 kilo ohm, or why it is not 1.05 kilo ohm, or why it is not 0.999 kilo ohm. Why you say that exactly it is 1 exactly? 1 kilo ohm means exactly, if we talk about accuracy, we mean that it is 1 and we have infinity number of zeros after that. So the probability of having exactly this thing actually is just 0. But if I asked you what is the probability that this resistance will be between 0.999, for example, and 1.001 kilo ohm, this is not 0. This can be some value about this. So actually we don't have perfect manufacturing for anything. So always we have some uncertainty. So we have always accuracy problem. Of course, we cannot have infinity accuracy, and we have limitations in measurements. Even if I measure the resistance of this resistor with some, for example, avometer, okay, even this resistance, this measuring device will have some impact on the measurement. It will add some value or reduce some value, as far as it will be noisy, as far as we have limited accuracy. So in real life, forget completely about certainty, about deterministic. So we don't have deterministic, and I mean by deterministic is 100% accuracy. This does not exist in life. Okay, we might have systems with 99.99 but we don't have 100% in anything. Okay, so now we have this resistance which has some uncertainty, and we can represent this resistance, for example, as Gaussian distribution, for example, and in this case it can be something like that. So this is actually the probability density function representing the uncertainties, or representing how the value of this resistance might change. So maybe the mean of this resistance can be 1 kilo ohm. This is the mean, but it can has also some other values. For example, here is 0.99 and here we have 1.01 and so on. So it is the reverse. So it is here 0.99 and here 0.01 and so on. So this is the probability density function of the distribution. Okay, now this uncertainty or the probability density function, the reason is because of our lack of knowledge. We don't have the ability to measure anything with 100% accuracy. This is not possible because we have limited accuracy in every of our measuring devices, as well as we have like imperfect manufacturing process. We cannot be 100% sure. We can be, as I said before, we can be 99.999%, but we'll never be 100% sure about anything. And because of that, we have lack of information or lack of knowledge. This lack of knowledge usually is represented as like with probability theory. So we can represent them with probability theory. So in this case, we can say, for example, about this resistance, that the resistance equal to 1 kilo ohm plus, for example, delta. What is delta? Delta is the uncertainty about the resistance. So this will be the uncertainty, and it has some kind of distribution or of behavior, as we will see later. Okay, is there other kind of uncertainties? Yes, there is another debatable one actually, is the random by nature. Actually, here in the slide it was given first. The random by nature, it means that it doesn't matter how knowledge you have, you will never be able to model the system as a indeterministic way. Okay, and the reason here is not because lack of knowledge. Here, because the process itself is random. Of course, it is a debatable. So some people say that it is not possible that to have, because the life here is we have always some logic behind every process, and if we don't know the logic or the reason behind this process, so we represent it as a random process, but it doesn't mean that it is random by nature. But other people say that no, it is random by nature, mainly like in thermal noise or in quantum mechanics, that they say that for example, the location of electron at any time, it can be represented as a random process, not because of lack of information, but by nature. So we cannot have the momentum and location in the same time. It is called uncertainty principle. Anyhow, we will not go about deep in the philosophical debate about this. So, but what we are interested in is the second type, is the uncertainty because of lack of information. So we have always lack of information, lack of full information. So because of that, we have always some kind of uncertainty, and this uncertainty, what we are using in when we need to compute the probability of any event. So the probability of any event is the uncertainty of that event to happen or not happen. For example, if we assume about, or if we take example about a process which has only two outcomes. For example, head and tail, if you throw the coin, or it can be, for example, raining or not raining tomorrow. Okay, it can be the car in the morning, that the car will be okay or it has some damage. So if we assume such kind of process that it has two outcomes, and we have some uncertainty about these outcomes. So if we assume that or we represent this with probability, so we can say that, for example, probability of A, assume that we have either A or B. So we have any process can be represented either as A or B. A, the car in the morning is okay. B, the car in the morning will not start up. Okay, A is to getting head, B to get tail if you throw a coin. A, it will rain tomorrow, B will not rain tomorrow. So those things that are A and B, so the examples that I gave now, they are mutually exclusive. It means that they cannot be in the same time. You cannot get head and tail in the same time. You cannot get rain and non-rain in the same time. You cannot get the car starting and not starting in the same time. Those are mutually exclusive events. Okay, the probability of A actually gives you your uncertainty about the event. So if the probability of A equal to 0.9, because the total probability is equal to 1, it means that the probability of B equal to 0.1. In this case, of course, you have more, you should have more belief in A than B, because the chance of A to happen is much larger than the chance of B to happen. Okay, the worst case from certainty point of view is when you have probability of A equal to probability of B equal to 0.5. In this case, it is 50-50. In this case, it's 50-50, and this reflects the highest uncertainty number. So the highest uncertainty is not 0.9, 0.1, is not 0.99 and 0.01. Actually, the highest uncertainty when you have the probability of A is the same as the probability of B, and those equal to 0.5. It is, for example, if in a quiz, so you have a quiz today, and one of the quizzes that you don't have any answer. So the probability that, let us that the question can be, you have to select it is true or not. Only that you have only two choices, and you have no knowledge, or you have your knowledge about this question is 0. Okay, so you don't have anything, you cannot make any decision about this. So what is the best way to do is just to make a throw coin, and you said that if it is head, I will mark it as correct, and if it is tail, I will mark it as wrong. So because you have no information about this, and this is actually the worst case. This is the worst case. Sometimes when you have higher probability, then of course you should go to the higher probability if the risk is the same. If the risk is the same. For example, if the risk of taking A is the same as the risk of taking B, and the probability of A is 0.55, it means that the probability of B is 0.45. So if we are looking for higher probability, then of course you will go to the 0.55, even it is slightly higher than the other one, but you should go to that one if the risk of taking A and B are identical. Okay, so the concept of probability that it is a mathematical branch which give some measure of this uncertainty, our uncertainty about any event to happen or not happen, or some event to occur or something like that. The probability is a branch of math to give us some numbers. So when we talk with numbers, it is much better to remove any fuzzy concept about the item. For example, if I told you that your car in the morning will most probably it will not start up because of some problem. Okay, most probably, or I think it might not start up, or it is just words. In this worldly kind of talking, we can, as a human, we can have some like concept out of that, but first it is hard to give it to a computer to take some calculations. The second thing, also it is hard for us to take a decision based on that. Okay, however, if you can give me more number, like quantify this in words, for example, to say 80% your car will not start tomorrow, or 90% your car, because I can see that the battery is almost empty, and 90% of your car will not start tomorrow. Then I will start making another arrangement how to go to my job tomorrow. Okay, for example, call taxi or something. Okay, but if you say that, okay, it is 40%, 60%. So based on these numbers, it might be clearer for me to take the decision. Okay. The last thing that I want to say before in this part is about to give it more a clear way how to think about the lack of knowledge. And now we said that when you throw the coin, you can have head or tail. Okay, it is a random process for you, for me. It is a random process. However, why it is random? It is random because it is we have lack of information. It is not random by itself. It is not naturally random. It is random for us because we don't have information. However, if we can build such equation that y, for example, equal to 1 if it is head and 0 if it is tail. Okay, and this y is function in what? Is function in many parameters. For example, one parameter is the initial condition. The coin, is it at head, face, or tail, for example. B is, for example, the force that you throw the coin. C, the weight of the coin. D is the ground characteristic that the coin will go or will land on it. E, and so on. So if you can have all information about the process, and more importantly that you was able to build the function, so you know the function and you have all the parameters, then this process is not random anymore. It is not random because now I can tell you with a probability, for example, 99.9% that you will get head or tail. Because I have the function, I have all parameters, I measured everything. Of course, you will not be able to get 100% because even if you give me, for example, the weight of your coin, but the weight, it will be only roughly weight. It is not 100% weight. It is not 100% the force that you throw it with it. So the force, you can plus minus delta, the weight plus minus delta. Maybe only the initial phase is, you can say that it is correct, but even it can be biased. It can be some, for example, the person that who told you about the coin, he might misread it or maybe lie about it. So we have always some uncertainty everywhere. However, we can resolve the problem. So once you have 99.9% accuracy about this process, so it is hard to say that it is like it has highest uncertainty as it is in the blind coin throwing. Blind coin throwing, we call it like maximum uncertainty if it is 50% to be head, 50% to be tail. But if you have the function, then you can handle these probabilities, and then you can have some like more accurate estimation about the result. It is the same actually happen, for example, in this battery car. It just came to my mind now. This battery car that it has. It is 20%, and I may say that I don't know if it will be enough to start your car in the morning or not. However, if I know the function of battery discharge, it is called internal discharge of the battery, the age of the battery, and many other parameters, then I can have more accurate estimation about the car it will start or not. Okay, so this actually building this kind of function, it can be done in functional way, but it is like deterministic. So we build a function and we start to study the force, Newton's law, and blah blah blah. Or it can be based on machine learning. In machine learning, that we give as inputs this to the machine, the inputs that we have from the experiment and what happened. Was it head or tail? The car was okay or not? And then the machine learning, it can build this or capture this map between the input and the result in the output. So this is very important to start with because in this course, as I said, on this part, we are not going to explain everything related to probability because the topic is very wide, but at the same time, it is important to have these concepts because they are very, very important to understand them. Okay, I stop here in this part, and then the next part, on next clip, I will talk about foundations of probability theory and how to extend it to the Bayesian theorem, which is the foundation of probabilistic reasoning. Thank you very much and see you in the next clip. Bye.